Okay, physics kids, it's time to talk a little bit about lenses. So you got the, hopefully you got the idea on mirrors and that mirror lab. Hopefully that worked out for you. But the idea we're after here is, we'll go back a couple of slides here, going back to here, is we look at lenses and we see that we have two different types of lenses, okay? Now, this is obviously our concave because it's caved in. Here's our convex. The one we're going to worry about literally is we're going to talk about the convex right here. We don't worry so much about the concave. We're just going to talk about the convex for a second. And what we're after is we're going to do the same basic idea that we were after with mirrors, because there's the really cool applications you can put together when you look at lenses and how they can actually work. So the best way of doing that is by doing a ray diagram, just like we did with the mirrors. And what we have here, it's in your notes, is I got a picture. It's under the magnifying glass section. It's got a picture showing a convex lens in the middle. Now, you notice, just like we had before, we've got focal points. Now, this time we've got two focal points. Here's your focal point. Here's your focal point. What that means is that all the light coming from a long distance would all go into that point right there. That's the focal point. Okay, every lens has its own focal point. Some are larger, some are smaller, depends on the lens you're working with. Okay, so whoops, go the wrong way here. My bad. Hold on one second. Okay, so if we take a look at this lens in particular right here is fairly thin, and so it has a fairly long focal length, which it shows right here. Here's the other focal length right here. Now, out here, which you usually have, is going to be something called 2F, which isn't drawn in here. But as long as we have the focal lengths, we're good to go. Okay? Now, just like before, we've got an object right here, and this will be an arrow. In our lab and in your little activity you're going to do, we're going to use a candle. So right here, we're going to pretend that's a candle. Now, the photons are going to emit from this candle. And where are some of the photons going to go? Well, some are going to go straight ahead, and they're going to hit the middle of this lens. And according to the focal length, what's it tell us going to do? Those photons are going to bend down through the focal point right here. They go straight, come down, and they go all the way through. You following that? Because they head off in this direction. Now, what we also have, there are some of those photons are going to head, and the photons are going everywhere. They're going this way, they're going that way, they're going all over the place. But another set of photons, they might head down through the focal point on this side. If they do that, and they keep on traveling to the lens, well, what direction are they going to go? According to the focal point here, it's going to head off in that direction. Now, what you end up having is you end up with the lines crossing right here. And just like before with the mirror, when they cross right here, guess what shows up? We get an image. And in this situation, it's called a real image, because if I put a piece of paper right here, what would show up in the piece of paper? An image of what's over here. This is the basic concept they came up with 120 years ago with movie projectors, cameras, everything. They found out that if you had an object here, put it through a lens, it would give you an image here, either on a screen, on a film, whatever. Now you notice it's upside down. Okay, it's inverted, but it's real. You have a piece of paper right there. Okay, so what you're going to do in your little lab activity is we're going to take this basic idea and we're going to move this thing around and see what happens to the image. Okay, now what's really cool about that is that sometimes you get some funky things going on. If you have, right now, you've got the object inside the what? It's inside the focal point, okay? So now if it's inside the focal point, some of these images, or some of these, photons, they're going to go straight ahead and they're going to bend down through the focal point, right? Okay? Now, also, some of those photons are going to come straight down right through the middle of the lens. And when they do that, they're not getting bent at all, okay? They're going to continue on straight in this path like this. Well, if you were to draw a line from the photons coming from where it's bent right here and the photons coming from the middle, and you follow those all the way back up into here, guess what they do? They cross. They cross over, and guess what you see right there? You see a virtual image. You see an image right here of whatever this is. What do you notice about it? It's huge and it's erect. It's straight up. There's our eyes over here, okay? And we see this all the way over here. This has now turned into a magnifying lens. And what's cool about that is what you can do if you put objects inside the focal point. Think about tools in science that you might have in biology or anatomy and phys or AP Bio or whatever else that might use objects put inside the focal point of a lens. Or think about astronomy too, whatever. But that's the basic idea. You got two different situations. You've got the lens right here where the object is outside the focal point and where it's giving you an image. And then down here, you've got the object inside the focal point and it gives you this virtual image over here. Okay, so use this idea, use this concept to go ahead today and we're going to work on a little lab. It's probably going to be the next 2 days or whatever. Work on a little lab activity that's going to show you what actually happens with lenses as we move the objects around. Okay? All right, let me know if you got questions. Talk to you later.